Hey everyone, in this video we're diving into the world of machine learning and I'll be showing you how to implement 6 different models that are essential for any data scientist or machine learning enthusiast. Whether you are just getting started or looking to expand your knowledge, this video will cover everything you need to know about simple linear regression, multiple linear regression, polynomial regression, support vector regression, decision trees, and random forest regression. We'll be walking through each model step by step using real data so you can see exactly how they work. By the end of this video, you'll have a solid understanding of when and how to use these models and you'll be able to implement them confidently in your own projects. But before we dive into the models, let's talk about the tools that we'll be using. So basically, we'll be using two tools that are Jupyter Notebook and the other one is Google Colab. So for the sake of this video, we'll be using Jupyter Notebook, but I'll also show you how things are done in Google Colab. First, let's start with the problem description. So imagine you're working for an MNC as a machine learning developer, and they say that they give you this data set and they ask you to create a model in which if we enter the experience of a person, then we can predict that person's salary. So you're basically given this data, the years of experience is given and the salary is given. So, for example, if the years of experience is 2 years, then that person's salary is 43,525. So, and similarly, it goes on to like 10.5 years, the salary is the most, I believe. So, the simplest form of machine learning regression model that we can apply here is the simple linear regression. So, let's jump straight into it. So this model is all about finding a straight line that best fits the data. Simple linear regression is a great way to understand the relationship between one feature and a target variable. So as we can see here, our salary is the independent variable and the years of experience is the dependent variable. So we need to make connections between these two things and the simple linear regression will help us in doing that. Okay, so now let's jump into the regression model code. So the first thing you have to do is set up your environment. I believe you can watch any YouTube video and learn how to use it on Notebook. So I'll be not doing that and I'll just explain the code, how things are done because I have to explain 6 regression models in just a single video. So the first step is importing the libraries. So we need 3 libraries. The first one is the matplotlib.myplot to plot the graph, which will let us see in visualization of the training set results and the test set results. Also, we need pandas because we are working with a data set and we need to convert the data set into a data frame so that we can access it using the next library, which is called scikit-learn. And we'll be using scikit-learn for all our machine learning models, especially in regression models. Okay, the next step is to import the data set. So we just write data set equal to pd.read csv. So pd is pandas and read underscore csv is the function. And inside the function, we write the name of the file. As you can see, this is the salary dataset.csv. So we just write the same thing here. And then we divide it into two parts, basically x and y. So x is basically the independent parameter and y is the dependent parameter. So the first column that you see here represents all rows. We select all rows and then also we select all columns minus one. So what we are doing here is we are just selecting all the rows. So rows are basically these horizontal lines. So we are selecting all rows and for x we are selecting all the columns minus one. So basically we are selecting only this column. So this will be our x parameter and for our y parameter it is all rows and the minus one column. So indexing in Python, as you all know, if you want to start from the end, it starts from minus one and then this would be minus two. So basically the salary column is -1 column. So we are signing it here as -1. So when you do this, I'll have to also run these. So you can run all these cells using this run button here. So you have to also import these libraries. I'm not going to show you how it's done. It's very basic and very simple. All you got to do is go here and click on this terminal, and once it gets open, so all you have to do is write uh, if things. So this is the only thing that you have to write. And as you can see, all my requirements are satisfied. So because I have all these libraries to install, so this is how you can install any library. Also, what you can do is if you are unable to install anything, just go on Google and write pandas 5. Okay. So if you go to this 5, it will show you how to install. So this is the code you need to use to install any library. Basically, I installed all my libraries like this. So coming back to the code, so let's run this part of the code. And actually, let's check what values are there. So simply, I'll have to write X here and just press run. So it gives me an array of 1.1, 1.3, 1.5, 2.0. As we can check from here that these are indeed the years of experience that we were given. And similarly, we can check for Y also. Yeah, so it gives us an array of the income. And you can see that it corresponds to X like 1.1. For 1.1, the salary was 39343. It may be in dollar, it may be in rupees, so we don't know, and it doesn't matter as a matter of fact. So the next thing we need to do is split the data set into training set and test set. Okay, so for application of any machine learning model, this is one of the basic steps. So what happens here is first we divide the data into X and Y. X are the independent variables and Y is the dependent variable. And then again we divide that data set into two parts, that is the training set and the test set. So we are splitting the data set into four parts. So those four parts would be X train and Y train. So the corresponding value of X goes to the corresponding value of Y. And similarly for the corresponding value of X text, the corresponding value of Y text is given. So for that we use a scalar, that is scikit-learn, and we select the model selection model. And from that module we use train test split function. So this function is used to split the data set. And we are using 1:3 ratio or 1/3, which means that 33.33% of the data will be present in the test size and 66.66% of the data will be going into the training set. So, so basically, we do this just to find out the accuracy of our model because this is the complete data that we have. So, how will we check if our model is working correctly or not? So, what we do is reserve some part of our data to check if our model is working correctly. So, whatever you see here in test, like this X test and Y test, these are reserved for checking our accuracy of our model, and only X train and Y train are put into the regression model so that it can learn, and using some mathematics, it can find relation between X train and Y train and then implement that connection on X test and Y test. So now the next step would be to train the simple linear regression model on the training set. So basically we are using the linear model module from scikit-learn and importing the linear regressor function. So first we have to initialize the regressor. So we just do it simply by opening the parentheses. So the next step is we fit the regressor with extreme value. So what this does is it fits those values. For example, for extreme, if we put 1.1 and it will correspond to 39342. Then it will put 1.5 and it will correspond to 37731. So this step is completely random. So it will randomly select some particular values, this fitting test, and then we can find the values that are in test set and training set. For example, let me show you how this is done. So I'll just first run this thing. Yeah. Okay, so then I have to add a new cell. Okay, so if I write x in here, click run. Oh, so I have to write something. Yeah. So see, it selected 2.9. It is completely random. So see 2.9. So in exchange we got 2.9, 5.1, and similarly let's see what we get the white ranges. See, we get white ranges 5.6 is 4.2. So I know as a matter of fact that the value corresponding to 2.9 was 5.6642. You can also check it. So it was number 1, 2, 3, 4, 5, 6. It was six number, and you can see here 1, 2, 3, 4, 5, 6. So it corresponds to 5.6642. So this is the way splitting the data set works. I think. So then we have to fit these things into the regression model that we have here. So I'll just run this cell. Okay, so our first machine learning model is ready. So now we have to predict some results. So what we have to do is just consider one variable that is y for it, and we just write regressor dot predict x test. See, we didn't use the values of x test in training this regression model. So this value is completely new to this regression model. And let's see how this performs. So we are going to predict the test set results. And then we have to write y red to see what was the outcome. Okay. So for different values of x test, we got some different values of y red. So now what we do is we compare these y red to the y test that was there to get the accuracy on how accurate our model was. So we'll just visualize the data. The accuracy part, I believe we'll be doing in the future regression models because there is not that much point. I know that the accuracy here is very low, around 50 to 60%. That is why I'm not covering the accuracy part here because we'll be using more powerful regression models in the future. And I'll tell you accuracy over there. So when we visualize this, if you run this system again, it's the same. When we visualize this result, we see that the original points, see, this PLT dot scatter, extreme white ring. So the value of extreme and white ring are in this red red dots over here, and the regression model that we just made is the blue line. So as I told you, my simple regression uses a straight line for predicting and finding the best possible path to replacing a set of values. So as you can see, it does an okay job. See, it almost finds the middle path for all the points here. And this was for the training set results. But our model was trained on this. So see, we used extreme and widen. Our regression model was trained on extreme and widen, but still it didn't predict uh, any of them correctly. It only did at, uh, at most like two of them, like 2 points at most. Our model would have predicted correctly. So it is not one of the best models to use, especially if the data set is random and non-linear. So let's check how it did on our test set. So if I run this thing again, yeah. So see, it did somewhat better. The set was it created within 1, 2, 3, 4, 5 values, but it is just pure luck. Uh, and nothing else. If I rerun it again, see the values might change. Yeah. So The values will change if I change everything from starting. What we can show you from starting again. So if I run all of this again, then this thing will also change. Yeah. So this time it predicted the 1, 2, 3, 4, 5 again. Nice. So it's completely random. The splitting of the data set is completely random, and it was just sheer coincidence that it again predicted 5 correct values. But as you can see, that these two values are not correct, and the one in the starting and this one in the center was not correct. So we need something better than that. So the next model that we will be learning is multiple linear regression model. But first, let me show you how this is done on Google Colab. So you'll have to open this Google Colab, and then for importing the data set, you'll have to go here. And so it is basically a cloud-based service. So what it does is it connects you to its server, and then basically you don't need to import any libraries because most of the libraries come pre-installed in Google Colab. It was basically made for machine learning. So once you are connected to the server, all you need to do is load that file, that, this file that is the slide.csv. You have to download it from my GitHub, and then you have to just click on upload, and from here you have to upload. Okay, so for example, this is my dataset, so I'm just going to click here and click open. Okay. So as you can see, my dataset was fetched over here. So all we need to do is just click on this button, and all of these things will execute the same way they executed in Google, uh, rather than uh, Jupyter Notebook. So the next thing is importing data set. So I'll just so it's a bit slow as compared to Jupyter Notebook because it's using a server-based approach rather than using your computer's CPU. And let's see how this thing does. Does it do anything better than Jupyter Notebook, or is it the same? So let's visualize everything. Okay, so it looks like the results are probably similar, and because the model was same, so CV on, yeah, only one value was correctly picked by a model, and in that case there were how many? 5 or 6 of them in this one. So it was pure coincidence that we got 5 answers over here. As we can see, we got only one answer over here. So it's up to you if you want to use the Colab. I showed you how to explain. All the code you have to write it yourself. I would recommend you write it yourself. Although you can go to my GitHub account and copy the code from there. It's completely open. So now let's move on to the next model that would be multiple linear regression model.